Hi, my name is Mr. Wandell, and welcome to AP Environmental Science, also known as APES. This is going to be Chapter 1, Section 1, and the very first of our video lectures, so I hope you do enjoy it. Our graph here is going to show us kind of the progress of humans over time, and you can see some of these major events that really led to some boosts in population. It's kind of something overall to keep in the back of your mind, not super important yet. Some of the things that you do need to know are these terms, and right off the bat, what is the environment, you may ask? And the environment is a combination of things, but for us, we're looking at the biotic and the abiotic section, or factors, and ecology then would be the study of how they interact. So an abiotic factor would be something that's not alive in the environment, like the water, or the sunlight, or the soil, or the air, while the biotic would be the living things, like the trees, or the squirrels, and the rats, and all those things that are alive. And so for ecology, we may be looking at how much water does a tree need in order to grow, or how much oxygen in the air does a squirrel need in order to live. So there's a lot of different things we could look at with ecology, and those are just a couple examples. One of the big misconceptions with environmental science is that it is equal to environmentalism, and that's really not true. Environmentalism is a political and ethical movement in which there are groups or people that are trying to protect the environment with regards to their agenda. And so some of these people may be seen as tree huggers or hippies or whatnot, but this is different than environmental science. These people have some sort of an agenda they're trying to push. And so environmentalism, I kind of picture the people on the whale watch boats where they attack the Japanese whaling ships with the stinky oils and the smoke and whatnot. Environmental science is a real branch of science, and it's something that combines a lot of different types of sciences and even social sciences into one larger picture. And so environmental science is really looking at our impact and how much we, as humans, interact and connect with the rest of nature. And so this portion right here is really good definition for environmental science. It's important to remember that environmental scientists don't necessarily work for the EPA or other protection agencies that are focused on protecting the environment or studying in that aspect. There are environmental scientists that work with lumber companies and oil companies to make sure that they are extracting those resources responsibly. Let's keep moving on. Sustainability. This is a really big part or portion of our curriculum here. Sustainability is the ability of a system to survive and function over time. And I like to think of sustainability, in terms of my bank account. So let's do a hypothetical scenario here. Let's say I've got $1,000 in my bank account. If I went out on a shopping spree and spent 800 of that $1,000, I'm not off to a very good start of that bank account surviving and functioning over time. If I spend it sparingly or invested in something, let's say I bought a lawnmower and then started a lawn mowing business in my neighborhood, I would have the potential to make it replenish itself and potentially exceed itself. So sustainability is kind of how we can use our resources effectively to make them last, which is a really important thing. Speaking of resources, they are anything that we can obtain from the environment to meet our needs and wants. And so the three examples I picked up here were the sun, whales, and this would of course be crude oil. Some really nice gunk there. The first type of resource is a perpetual resource. A perpetual resource, there's really only one of them, and that is the sun. And the sun continues to give us solar energy. It does not stop. It is not going to stop within the human time scale. Scientists predict the sun's got a couple more billion years left before it finally explodes. So we consider that to be a perpetual, never-ending never ceasing resource. It's always there and it never ends. Renewable resources could be things like trees or clean water or soil or lumber from a forest. These are things that replenish on the human timescale, which means in a human's life, they can replenish themselves. And the kind of convention for that is that these things will replenish in less than 100 years. And the example I picked up here is the whale for a renewable resource. So these used to be really prized animals to hunt because they had a lot of meat on them and because the oil could be used for heating and for lamps. And so they are a renewable resource. They will replenish, reproduce, and grow in less than 100 years. However, when we were hunting whales, we were so efficient at it that we pushed them to almost becoming a non-renewable resource. We almost pushed them towards extinction. And so a renewable resource can become non-renewable. A non-renewable resource is something that is used faster than it's being produced. The big classic example of a non-renewable resource is oil. Many millions of years to make this cup of oil, we use it up much quicker than that. And so it's not something that is renewable, it is non-renewable. Once we use up all of the oil, it's not going to replenish within our human lifespan. And so that almost became the case with whales, right? Had we hunted them to extinction or pushed them all the way to the brink of extinction where there were no whales that could find one another to reproduce, then they'd become that non-renewable resource where they're not going to be able to replenish. This is some of our big environmental issues we're going to study this year. Population growth is the first one here, and that one kind of precipitates to these other ones. And so I like to think of population growth as one of the biggest issues facing the Earth. Population growth is simply too many people on the planet, and along with that comes increasing our resource uses. So in order to supply these people with the food, water, and luxuries that they want, we have to use up more resources, and we push more of the renewable resources to becoming non-renewable, and we deplete more of our non-renewable resources. Along with all this population and resource extraction, we end up destroying or degrading the natural habitat, which can slow down some of those resources being reproduced, or kind of use up other ones we're not even sure we're using. That can also force premature extinctions. With really high populations comes poverty, and also that population number contributes to pollution. You've got more people around throwing out stuff. This picture here is kind of some of the big issues. We will cover these throughout the year. If you want to pause it and look closely at it, you're more than welcome to, but this is all stuff we will cover in detail throughout the year. Growth is a really important part of environmental science. There are 3 types of growth curves that you'll see. We've got 2 of them on this slide. The next one's got the 3rd one. The first one, and probably the one you're most familiar with, is the linear quantity, which increases by a constant amount of time, constant amount per unit of time. And so that one is our y equals mx plus b equation that you learned back in algebra. And you can see that this linear graph here is simply represented by the line. Our other type of growth is exponential, and sometimes we call these a J curve. A J curve is the graph at the top here. This graph is showing exponential growth, and it's the quantity, all right, so our y value is increasing by a fixed percentage of the whole in a given time. So every year, we're getting a certain percentage higher and higher and higher, and eventually that contributes to really, really rapid growth. Exponential growth is usually bad when we're talking about the environment. We're talking about your bank account. Exponential growth is really good, and hopefully you get a great interest rate or a great fixed percentage on that money in the bank account, and it can look something like this graph, and you'll be very happy when you get to the end here. This is the next type of graph. This is a logistic curve, and I'll just write that out here. logistic curve. Still trying to get down how to write with this thing. A logistic curve, it starts out just like a J curve and then becomes this S. And so that's because we're reaching what's called a carrying capacity. And that's one of the reasons why the really large population, that increasing population growth is a dangerous thing, is people believe that the Earth has a carrying capacity for humans. And a carrying capacity is simply a maximum number of organisms that an environment can support, meaning once these organisms reach a certain point here, the resources begin to become scarce. All right, whatever these paramecium need to survive, be it sugar or bacteria or oxygen, that starts becoming scarce because there are so many other individuals using up that resource, and their population starts to decline. And that could be a very scary thing if we're talking about people and not having enough of some resource we require in order to survive, something like clean water or clean air. Doubling time, this is a very important equation, and it's one that you're just going to have to memorize. Thankfully, it's fairly simple. So for doubling time, you take 70 divided by the percentage of growth rate, and that gives you the doubling time in years. And so the example problem we've got is a growth rate of 1.28%. So to solve for this, you would take the number 70 and divide it by 1.28. You do not want to take the decimal equivalent of the percentage. You want to just use the actual percentage. Plug that into your calculator or divide it, and you get a doubling time of about 55 years, which means that if we had a population here, this human population was 1 million people. 1 million. After 55 years, this population would then be 2 million. All right, I'm not going to try to write that out and waste all your time. But that's doubling time. So make sure you're very comfortable and familiar with that. And that's where we're going to stop for section 1. I hope you enjoyed the video. Please make sure you take some sort of notes that you can show me tomorrow in class. Feel free to rewind, rewatch any part you like. And if you want to give me some feedback on what you thought about it, I would be more than happy to hear what you have to say. Thank you very much for watching.